In our first section, we're going to define a lot of the terms that we're going to be using throughout this course. First, we're going to build up the idea of what an angle is and how to measure it. Now, the term ray refers to a part of a line that stops at a point on one side and keeps going on the other side. And if we take a ray and add it to another, or combine it with another ray that shares the same stopping point, then we have formed an angle. Now, that common endpoint is going to be what we refer to as the vertex. And it's going to make a big difference. When we start talking about measuring an angle, we're going to think of starting with one of our rays and rotating it about the vertex to end up at the other ray. And it makes a big difference which ray is our starting ray and which ray is our ending ray. The ray that we start with, we're going to call the initial side of our angle. And then the ray that we end with, we're going to call our terminal side. It turns out that if you start with one side and rotate it to the other, and then you start with the second and rotate it back to the first, those are going to end up being opposite angle measurements. One's going to be positive and one's going to be negative, as we'll talk about in just a moment. Now, an angle is going to be said to be in what we call standard position if the vertex is right at the origin, the intersection of the x-axis and the y-axis, and the initial side is on the positive x-axis, the right side over there. So if we start, say, for example, there, and then rotate it to this position, there we would have our angle in what we call standard position. Now, something that's important to understand, as I was saying a minute ago, the direction of rotation is important. Suppose we start in standard position with our starting side on the positive x-axis, and suppose we rotate it to about right here. Suppose we measure that, and it turns out to have a measurement of 75 degrees. Well, now suppose instead of rotating in that counterclockwise direction, suppose we had started again in standard position, starting on the positive x-axis, and we had rotated the same amount, but in the opposite direction, in the clockwise direction. Then we would end up with a negative 75 degree angle measurement. When you rotate in the counterclockwise direction, you get positive angle measurements. And when you rotate in the clockwise direction, you end up with negative angle measurements. So when you're thinking of signs of angles, all that tells you is the direction of rotation. Counterclockwise rotation, rotating in this direction, that's a positive angle measurement. Clockwise rotation, rotating in this direction, that's a negative angle measurement. Now, in that previous example, I was talking about 75 degrees. Well, let's define what a degree is. If you start on the right side and rotate all the way around so that you finish right back where you started, that would be 360 degrees. So by definition, 1 degree, which is usually going to be written just as 1 with a little degree symbol like that, is 1/360th of a complete rotation. So in that previous example, when we were talking about 75 degrees, that would be 75 360ths of a complete rotation. So it's going to help us to remember that 360 degrees is rotating from your starting side all the way back and ending up in the same spot. Now, some vocabulary words we'll use every now and then. Angles with measures greater than 0 degrees and less than 90 degrees are going to be what we call acute angles. So it might be, for example, something like this. That would be an acute angle. Now, an angle with a measure of exactly 90 degrees is going to be what we refer to as a right angle. And to indicate in drawings that we have a right angle, what you're often going to see is a little box like that, a square next to the vertex. When you see that in a drawing, you can assume that we're dealing with a perfect right angle, a 90-degree angle. Now, angles with measures bigger than 90 degrees and less than 180 degrees are going to be what we refer to as obtuse angles. So maybe starting over here and ending up over there, something bigger than a 90-degree angle. And then one you won't deal with a lot, but you will see now and then, when you have something that's kind of like two 90-degree angles put together, measuring exactly halfway around 180 degrees, that's going to be what we call a straight angle. Those are some vocabulary words we'll use occasionally in this course to talk about different sorts of angles. Now let's start talking about measuring. We talked about the fact that 360 degrees would involve rotating all the way around an angle or all the way around a vertex, and 1 degree is 1/360th of a rotation. Other than degrees in this course, we are often going to measure in what we call radians. Now, a radian, as it says here, is the measure of an angle of a circle that intercepts an arc equal in length to the radius of the circle. Now, to explain that, let's take a look at this drawing. Suppose we have a circle of radius r. Radius is the distance from the center of the circle to the outside. So this distance right here is our radius. And it's the same anywhere you go, so this distance here would also be the same radius. If the length of the arc on the outside of your circle in between two rays is equal to the radius, then we say that that angle measurement is 1 radian. So 1 radian represents an angle so that the arc of the circle would equal the radius of the circle. So half of a radian would mean that the arc of the circle is half as big as the radius of the circle. Or 2 radians would mean that the arc of the circle is twice as big as the radius of the circle, and so on. And a formula we're going to deal with that talks about how arc length and radians and angles are related to each other. If we look at this drawing here, suppose we have a circle with a radius of r and an arc length of s, and we want to calculate the radian measure of that angle. The angle measurement is equal to the arc length divided by the radius. This is how you calculate radian measure for various angles. You take the length of that arc and divide by the radius of your circle. So for example, here we have a problem that says a central angle in a circle of radius 6 inches intercepts an arc of length 15 inches. What is the radian measure of the angle? So thinking of that formula that we have there, to find our radian measure, we take the arc length, which this problem tells us is 15 inches, and we divide that by the radius, which is 6 inches. 15 divided by 6 is 2.5. So here our angle in radian measure would be 2.5 radians.